types of fruit. So it's pretty interesting to imagine that basically this part of the flower just grows and fills up with all this nutrients and tissues and becomes the fruit. And so it's kind of cool that it transforms like that into something that we can eat. All right, so we're going to wrap it up with ecology. That's how we wrap up every kingdom, thinking about why these organisms are important. Obviously, plants are incredibly important, in large part because of food webs. And so all of us are eating some kind of plant product. We really can't survive on the, just on meat alone. And obviously, we have some students out there that are vegetarians and maybe even vegans. And if anything, probably the healthiest type of diet is going to have lots and lots of vegetables in it. And so I mentioned earlier that dinosaurs ate the cycads, and this little food chain helps illustrate that. So here we have a Triceratops that's going to eat the producer here, being the cycad, creating the carbohydrates. And then maybe something like a T-Rex might eat the Triceratops, and we have a short little food chain. But the most important part of the food chain is our producer, in this case, a cone-bearing cycad. They're incredibly important for nutrient cycles. All sorts of nutrients are cycled with plants. So photosynthesis, in particular, is going to be cycling carbon, oxygen. They're going to cycle nitrogen, water. All sorts of stuff is moving around. Here we see nitrogen cycling, and even calcium, and carbon, and oxygen. Really confused why oxygen is not coming out of this tree, but that would seem to be something they should have here. But still a good little chart. Okay, we have all forms of symbiosis, including parasites. So a lot of people don't think about plants being parasites. I did mention in Unit 5 invasive ivy that can overgrow things and take all their resources. We talked about, so that basically functions like a parasite. And right here is a plant that's associated with another famous plant associated with a famous holiday. And it's actually a parasite. So I'm wondering if anybody out there can tell what this plant is, but it is mistletoe. And so what happens is birds will eat the seeds of the mistletoe, and then as birds do, they'll poop the seeds out somewhere else, allowing the plant to grow in like a new environment. And so like a bird might land on a branch and poop out some seeds, and then the seeds are able to grow right on these branches, and their roots go into this other tree, not really sure what it is, but and it starts to take nutrients from it. And I grew up in an area where we could definitely see mistletoe in the trees, and it was kind of weird to think that they were like parasitizing and taking its nutrients away. Then there's a picture of commensalism. These are epiphytes, which are sometimes called air plants. They don't really need soil, and they can grow on the side. In obviously very wet environments. They can grow on the side of trees and not really maybe have a big effect on them. So if you remember, commensalism is where one benefits and the other one is unaffected. So being up higher, maybe away from animals and stuff, benefits the epiphyte, and the regular tree just really isn't that affected. And then we've talked about mutualism. In our fungus notes, we talked about mycorrhizae, arguably the most important form of mutualism in the world, along with pollination. So this is a form of mutualism where organisms aid in flower reproduction while they get food. And so both the plants and the animals are benefiting. Here we see a bee with a bunch of pollen, even like pollen on its eye. And this is a fruit bat, which is the only pollinator of these particular fruit trees. It's kind of interesting. This is a huge packet of pollen. The bees have special adaptations on their legs, so if they can collect huge amounts of pollen and take it back to the hive. And so that's a neat picture. And then this is actually a picture I took of a bumblebee, and I've never really seen anything like this before or after. This was in a park in Malibu called La Jolla Canyon, which is pretty remote, close to Ojai. I was just kind of walking down the trail, almost done with this big hike, and saw this bumblebee kind of cruising around. Just happened to notice these big red packets of pollen on its legs, and took some pictures. Didn't come out super clear, but came out pretty cool, and really just shows those amazing packets. And then my camera lets me zoom in a little bit after I take a picture, so it's about as clear as I could get it. But you can really see how big these packets of pollen are. They're also really smooth, which was kind of weird. They look really smooth, where this one doesn't really look smooth. Anyways, okay, we use them for fuels. So again, this is a drawing of the Carboniferous period where we talked about all the forests were all like ferns and giant horsetails and stuff. And again, it is believed that as these forests for millions of years died and got buried in the swamps, over time they eventually became our fossil fuels. And actually, you might have heard that insects were really big in the past. So this dragonfly was probably the size of like an eagle, like maybe even like a bald eagle, like a big eagle, which kind of freaks people out. And here's the reason why insects can be larger. And I think, you know, some students might know this. It has to do with the amount of oxygen that's available in the atmosphere. So we think there was more oxygen in the atmosphere in the past, and the insects, the fossils of these insects were huge. And actually down here we see an early amphibian as well. We start to see maybe some amphibians starting to evolve in the Carboniferous. So it's kind of a cool drawing. And then obviously we use wood, you know, just straight up wood for burning and for fuel. And that was a big part of human evolution and the first form of major technology other than weapons probably and hunting tools and stuff was the ability to harness fire for our ancestors. Then we also get medicines and other products. So this is aloe, which can be used on like cuts and burns and stuff. And most of you have probably heard about that. And then this is actually rubber coming out of a rubber tree. And it's coming out of the xylem and the phloem. And it's just kind of this sticky substance that can be used to make rubber. And we obviously get a lot of medicines and other things from plants, and this is just, especially the medicine stuff, one of the reasons why we should be protecting our forests, taking care of our ecosystems and these plant resources, because they're providing us habitats and resources and food, and are cycling nutrients, creating oxygen, cleaning up the air from carbon dioxide, providing homes for millions of animals, and also creating important medicinal things that we can use. And actually the video, pretty sure the extra credit video this week is going to talk about some of those medicines. Okay, and that's it. So here we have just a couple of pictures symbolizing that we should care about nature and our forest. Don't know if you necessarily need to kiss a tree, but I think the concept of tree hugging is valid, at least symbolically, in that we should care about plants and nature and our forests and protect them because they're helping keep life on Earth alive. All right, all we have left is animals, which is going to be a pretty cool way to finish the year. That's it for